So in this last example that we're going to go through for today, example 10, the question will ask you to find the equation of perpendicular bisector of AB. So let's take a look at the question. Find the equation of perpendicular bisector of AB given the points A, 5, 4 and 3, negative 2. Hence or otherwise, find the coordinates of P on the x-axis if P is equidistant from A and B. Okay, let's talk about this later on. Okay, let's start with the first one. So let's just sketch out a diagram A and B. So we know for a fact that A is somewhere here and B is somewhere here. Okay, again, doesn't have to be accurate. Okay, then we have to draw the perpendicular bisector. So we need to, if we want to find the equation of the perpendicular bisector, you realize that we need the midpoint and we need the gradient of AB. So let's talk about the gradient first. So gradient of AB, okay, is again given by y2 minus y1 over x2 minus x1. So again, it will help you if you label this x1, y1, x2, y2. So we have negative 2 minus 4 over 3 minus 5. Okay, it's very helpful because when you label, you won't mix up the numbers. All right, so negative 6 divided by negative 2, we get positive 3. All right, so next we need to find the gradient of perpendicular bisector. So gradient of perpendicular bisector of AB, okay, is simply negative 1 over the gradient of AB, which is negative 1 over 3. Now that we have the gradient, we now need the point on the perpendicular bisector. So midpoint of AB, okay, just write down the formula again to help you refresh. So x1 plus x2 over 2, comma y1 plus y2 over 2. So x1 plus x2 is given by 5 plus 3 divided by 2. Y1 is 4. Y2 is negative 2 divided by 2. Okay, and I will get 5 plus 3 is 8 divided by 2, 4. 4 plus negative 2 is 4 minus 2. 2 divided by 2 is 1. So now we have a point on the perpendicular bisector 4, 1. So what we need to do is to find the equation of the perpendicular bisector. So equation of perpendicular bisector of AB is given by y minus y1 equals to m bracket x minus x1. Okay, please don't confuse this y1 and x1 with this one. You need to use the midpoint of AB. So y minus 1 equals to the gradient negative 1 over 3x minus 4. Okay, so y minus 1 equals to negative 1 over 3x plus 4 over 3. Add 1 to both sides. I have y equals to negative 1 over 3x plus 4 over 3 plus 1. So that will give me plus 7 over 3. Okay, now hence or otherwise, find the coordinates of point C on the x-axis if P is equidistant from AB. Okay, so what you need to understand is that the perpendicular bisector has this function, and that function is simply any points on the perpendicular bisector of AB will always be equidistant from A and B. That means if I select this point over here, this will be the equidistance. If I select this point over here, it will be equidistant. It doesn't matter where. Okay, as long as on the perpendicular bisector, it will be equidistant from the two endpoints of the line that it bisects. So in this case, when they ask you to find the coordinates on the x-axis, this is simply asking you to find the x-intercept of the perpendicular bisector. Sorry. So to find the x-intercept, I let y be 0. So let y equals to 0. I have 0 equals to negative 1 over 3x plus 7 over 3. 1 over 3x equals to 7 over 3. X equals to 3. Sorry, x equals to 7. Sorry about that. Now, answer the question. The question asks you for coordinates. So point P is given by 7, comma 0. Alright, so again, keep it simple. Alright.